Hello, this is Mr. Brooks, and welcome to Lesson 10.6, Circles and Arcs. In this lesson, we're going to find the measures of central angles and arcs, and we're going to find the circumference and arc length. Okay, in this lesson, there are many terms we need to learn. The first one is definition of a circle. A circle is a set of all points in a plane equidistant from a given point, and that given point is called the center, and you name the circle by its center. So on the right here we have circle P. Radius and diameter each have two meanings. Radius could be a segment that goes from the center to any point on the circle, such as segment PC here in red. And radius also means the distance from the center to any point on the circle, the length of segment PC. In this circle, segment PB and segment PA are also radii, which is the plural for radius. And congruent circles, of course, are circles that have the same size, so they're going to have the same radius. Diameter, just like radius, has two meanings. It could be a segment that contains the center and have both endpoints on the circle, or it could be the length of a segment that contains the center with both points on the circle, such as segment AB is the diameter of circle P. A central angle is an angle whose vertex is the center of the circle, such as angle CPA is a central angle, and angle CPB. CPB would also be a central angle. Okay, now let's look at example 1. Example 1 shows the results of a hour-by-hour survey that a research firm did that studied 3,600 people. To me, that is a massive survey. So the bigger the survey, the more accurate the data is going to be. And the participants were anywhere from 18 to 90 years old, so basically adults. And each participant was sent a 24-hour recording sheet to explain what they did for every day of the month of March for 3 straight years. So I think this is a pretty extensive survey, and the numbers here are going to be pretty accurate. As you can see, people are spending 31% of their time sleeping, which is almost 1/3, 9% eating, 20% at work, 18% on entertainment, 7% at must do. It gives the example of brushing your teeth there, and then 15% other. All right, so the question is, in degrees, what's the measure of the central angle for entertainment, the purple section, which is 18% of the time, 18% of the circle. Please pause the video while you try to figure this out. Get the measure of the central angle, which I will put 2 arcs on in white right up here. The measure of the central angle for the purple section for entertainment, you're going to take 18% of 360. Of course, there's 360 degrees in a full circle, and we want 18% of that. 18% is 0.18 of means time, so you're multiplying 0.18 times 360. So you're going to get approximately a central angle of 64.8 degrees. So about 65% of the, 65 degrees is the central angle, the one with 2 arcs on it. Quick check number 1 says that each section of the circle represents a measurable quantity. What is that quantity? Please pause the video while you try to figure this out. Hopefully you would agree that the graph is representing how much time is spent in each of these areas. So basically it would be the number of hours that the participants are spending doing these things. And part B says each section of the graph represents an average. Explain. Please pause the video while you try to figure this out. Again, the average they're talking about is the average of the 3,600 people that are doing this. Some people certainly spend more than 31% of their time sleeping, and others spend less than 31% of their time sleeping. And so it averaged out with all the participants, 3,600 people, to be 31% of their time. So that's the average they're referring to. Next part of the lesson talks about an arc. An arc is simply part of a circle. So a semicircle is an arc, and it would be exactly half a circle. A minor arc is smaller than a semicircle, so it would be less than half a circle. A major arc is greater than a semicircle, so it's going to be more than half a circle. The measure of a semicircle is 180. The measure of the arc is equal to the measure of its central angle. So in the middle circle, they want what's the measure of arc, RS? Well, it would be the measure of angle, RPS, all right, which is going to be a minor arc because it's less than half the circle. The measure of major arc, RTS, in the circle at the right, is going to be equal to the measure of angle, RTS, which would be 360 minus the measure of arc, RS, or angle, RPS. So in this case, we will be talking about central angles that are greater than 180. Example 2 asks us to identify the following parts of circle O: the minor arcs, the semicircles, and the major arcs that contain point A. So please pause the video while you try to figure this out. Try to write down the answers to all three of these before you resume watching. The minor arcs are going to be arc AD, arc DE, arc EC, and arc AC. All those marked in red or pink are your minor arcs. Semicircles and major arcs are always labeled with 3 letters, and minor arcs, as you can see, are labeled with 2. So the semicircles are going to be arc ADE, which starts at A, goes through D around E, arc DEC, which would be this one, arc ECA, which would be here, and last would be arc CAD, which is this one. Hopefully you can see all 4 of the semicircles. Now let's take a look at the major arcs. Arc AEC would also be called arc ADC. Starts at A, goes through D and E around to C. Arc DEC starts at D. Arc DE, through DEA, DCA, same arc. Then we got arc CAE, which would start at C, go around to E, call it CAE or CDE, same arc, and last ECD, which would start here, go around to D, which would be arc ECD or EAD. Hopefully you see all 4 of the major arcs as well. All right, now let's look at quick check number 2. Identify 4 major arcs of circle O that contain point E. Please pause the video while you try to figure this out. Okay, hopefully you came up with these 4 major arcs. Please try to make sure you understand which ones are which as I draw on them. Arc ECD starts at E, goes through C, all the way around to D. That's the first one, starting at E, ending at D. You can call that ECD or EAD. Next one, starts at C, goes through A and D, all the way around to E. That's the second one. All right, that's 2. Next one, starts at A, going to go through D and E, end at C. And the last one will start at D, go through E, C, and end at A. All right, there's your 4 major arcs for this circle O that go through E, that contain E. Next, we need to talk about adjacent arcs. Adjacent arcs are arcs of the same circle that have exactly 1 point in common, and you can add measure of adjacent arcs just like you can add measures of adjacent angles. All right, So arc AB and arc BC would be adjacent arcs, and the measure of arc AB plus the measure of arc BC would equal the measure of arc ABC. Hopefully that makes sense to you. Okay, example 3 asks you to find the measure of the following arcs. You have to find the measure of arc BC, measure of arc BD, measure of arc ABC, and the measure of arc AB. Please pause the video while you try to figure this out. Remember, the measure of the arc is the same as the measure of its central angle. So, the measure of arc BC is going to be the same as the measure of angle BOC, which is 32 degrees. The measure of arc BD would be the same as the measure of angle BOD, which would be 32 plus 58, which is 90 degrees. The measure of arc ABC would be the measure of angle AOC, which is simply 180 degrees. We are talking about the measure of this semicircle right here, not the other side. And last, the measure of angle measure of arc AB would be the same as the measure of angle AOB, which would be 180 minus 32 degrees, which comes out to be 148 degrees. It's the measure of arc AB. This is the measure of central angle AOB. Okay, quick chunk number 3 asks you to find 4 different measures. Measure of angle COD, measure of arc CDA, measure of arc AD, and measure of arc BAD. Please pause the video while you try to figure these 4 things out. Alright, hopefully you're going to agree the measure of angle COD is 58 degrees because it's going to be the same as the measure of arc CD. Right here is angle COD, and that's going to be the same as the measure of arc CD. They're both 58. Measure of arc CDA is going to be this semicircle right there. So hopefully you agree. Measure of that semicircle, that arc is 180. Measure of arc AD right here is going to be 180 minus 58, which would be 122. It's going to be the measure of arc ACD minus arc CD. Measure of arc BAD, which starts at B, goes through A, all the way around to D, is going to be 360 minus quantity of 32 plus 58. You're going to add those together, that's 90, so it's going to be 360 minus 90, which equals 270. Measure of arc BAD, the black one, is going to be 270. This ends the video on lesson 10.6, part 1, which was over central angles and arcs.